Assalamualaikum warahmatullahi wabarakatuh. I'm Nur Hafida binti Muhammad Nasir, matrix number CF190050. I and my friend want to present about our project Advanced Traffic Engineering, which is about signalized intersection. We are from group 16. My group members is Ahmad Zikri bin Muhammad Nasir, Muhammad Ashraf bin Munawar, and Muhammad Ammar Zahril bin Kusai. Introduction. Signalized intersections are achieved by planning techniques that help the satisfactory operation of the network depending on the required requirements. Intersections are designed to allow drivers to cross other traffic streams or switch from one stream to another to change their direction of movement. Road intersections in Malaysia are controlled by a system of traffic lights and without traffic lights. The quality of traffic on the entire road network may be impacted by the distance between intersections with traffic signals. If the traffic signal cycle is not created in accordance with demand, this will worsen. The location of the intersections that we have chosen is Jalan Robena 1, Taman Robena 86400 Parit Raja, Johor. The objective of this study is first is to analyze on the performance of the signalized intersection. Second is to propose improvements to improve the traffic flow at the intersection and estimate the percentage of improvements from the current traffic flow.
Hello, my name is Muhammad Zahril bin Kusai. My matrix number DF190064. I would like to present to you about the methodology of this project. Firstly, we need to prepare equipments. Equipment is very important to ensure the safety of students and to make sure that this project can run smoothly. First equipment is measuring tape. Second is flags. Third is safety cones. Fourth is safety vest. And lastly is stopwatch. There are few procedures to do this project. Firstly is we need to observe the traffic flow for 1 hour in 15-minute segment, and then we need to record the observation data. After that, we need to measure and record the line width in meter for each approach. Then during each page, we need to measure and record the green time and cycle time. After that, we can calculate saturation flow, transfer value for each approach, total value of green time, inter-green time, and total time per cycle. And lastly, we can establish the average stop delay per vehicle in second and level of service (LOS). Thank you.
Result and data analysis. For the first traffic flow and PCV for the left lane approach from the north direction. Okay, traffic volume 1 hour is 1051 vehicle. Conclude from class 1 until class 4. The PCV value total is 911.72. For the traffic flow and PCV from the right lane approach from the north direction. The total for all class 1 hour is 554, and the PCV value total is 482.26. Traffic flow and PCV for the right turn approach from the north direction. The total 1 hour traffic volume is 100 and total PCV value is 75. Traffic flow and PCV for the right lane approach from the south direction. Total traffic volume 1 hour is 490 and the total PCV value is 441.94. Okay, for the traffic flow and PCV for the left lane turn approach from the south direction, the total traffic volume 1 hour is 376. Conclude class 1 until 4, and the PCV value is 343.56. Okay, for the traffic flow and PCV for the left turn approach from the south direction, total traffic volume for all class 1 hour is 111 and the PCV value total is 93.47. For traffic flow and PCV for the left turn approach from the west direction is traffic volume 1 hour 23 include all class vehicle, and the PCV value is 18.14. Okay, the last traffic flow and PCV for the right turn approach from the west direction include all class. The traffic volume 1 hour is 236 vehicle, and PCV value is 188.08.
My name is Ashraf bin Nawar. I will talk about the analysis and results. Okay, first of all, from the data we get in the field, okay, we convert it, we interpret it into the formula. Firstly, is to determine the saturation flow. Okay, second is to determine the Y value. Okay, and then we can determine the total time per cycle, which is L. Assume amber time A is 3 seconds, and oil rate interval R is 2 seconds, and driver reaction time is 2 seconds, and intergreen time I is 5 seconds, and we can get total loss time from that. And then optimum cycle time using a Webster method, and then a fourth step is to calculate the total effective green time. We can get effective green time, and then we calculate the actual green time, and controller setting time K. Okay, we use this formula. And then lastly, we can calculate the average delay per second and determination for LOS, level of service, using a table. Okay, by this slide, we can determine the saturation flow S using this table at A, and B, we can use this table to determine the Y value. After we get a Y value, we can calculate the average delay per second, and we can determine the level of service. Okay, overall, the level of service at this area is very bad, more than 60 seconds, which is 1 minute, and this can be concluded that we can use other alternative to reduce the level of service at this area. Okay, thank you.
Okay, next is improvements to improve the traffic flow at the intersection. First is improving turning lane. Many busy intersections are burdened with heavy traffic making both right and left turns. Studies shows that a well-designed turning lane installed at a stop-controlled intersection can reduce accidents by up to 55%. Second is installed roundabout. Roadway engineers are incorporating roundabouts in new street designs and road improvements areas because they are proven to be effective at reducing car crashes by upwards to 87%. Third is adjust cycle time. The duration of the cycle time affects delay to vehicles passing through the intersections. Next is properly set traffic signals. The increasing rate of red light running automobile accidents occurring at intersections, many more catastrophic injuries or fatalities than ever before. And last is propose additional lane. Adding new lanes can improve the traffic flow through the area. New routes can increase mobility in the area by providing more reliable access to the areas that were difficult to reach with the existing roadway or intersections system.
Okay, for the conclusion, first, the major of the traffic within the intersection was caused by human mistake owing to a lack of knowledge of the traffic congestion. Okay, we performed the survey manual. There was a potential that we commit unintentional error. The traffic survey may also be used by authorities for traffic monitoring. And the last, traffic forecasting, model calibration, and validation. The collected data and result can be utilized to perform further study and enhance the control system. That's all from me. Thank you.